Hello students, welcome back. Now let's go to section 4, intercepts and asymptotes. The first half of section 4 is going to be review of sections 2 and section 3, and some review from module 9 as well. Okay, intercepts. This is how we describe intercepts in chapter 2 of our textbook, or lesson 3b in terms of my lesson notebooks. For y-intercept, plug in x equals to 0 and so for y. X-intercept, put y equal to 0 and so for x. The reason? The y-intercept is a y-coordinate value where the curve hits the y-axis. So here's the y-axis, so x-coordinate is 0. That's why. For x-intercept, vice versa. Now for graphs of functions, however, the equation is y equals to f of x. So plug in x equal to 0, you get y equals to f of 0. So that's your y-intercept. That was easy. And then for x-intercept, put y equal to 0, so you get f of x equal to 0. And there goes an equation to solve. Solve it, and you're going to get appropriate x values. Those are the x-intercepts. And here are the rational function version of the y-intercept and the x-intercept. Y-intercept, plug in x equal to 0, so there you go. And for x-intercept, the function value, y value, has to be equal to 0, so the numerator has to be equal to 0. But, big but, don't just jump into the numerator. The numerator and denominator may interact with each other, as we saw example from section 1 of this notebook. And there will be several more as a matter of fact. So work out the numerator and denominator at the same time and simplify to the lowest term, and then work out the zeros from the numerator. Okay, so much for the intercepts. Let's go to the asymptotes. Horizontal asymptotes and vertical asymptotes. Horizontal asymptotes come from the end behavior, so we take the asymptotic estimation. We simply take the leading terms. By the way, there's a bit of a parallel between horizontal asymptotes and the y-intercept computation. We don't need it anymore here, so let's compare this, the y-intercept computation and the horizontal asymptote computation. Here, we take the last terms only, a0 over b0. Here, we take the first terms, am x to the nth power over bn x to the nth power. Last, first. See the parallel? So it's going to be a good idea to match this horizontal asymptote and y-intercept together and do that in a single step. That's what I'm going to do in all the exercise problems from here. As for doing two things in a single step, it's going to make even bigger sense to match x-intercepts and vertical asymptotes together. From the numerator, we get zeros, and that's going to be represented by x-intercept in graphs. From the denominator, you're going to get poles, and they're represented by the vertical asymptotes in the graphs. But then again, don't just jump over to denominator or numerator separately. They may interact with each other, and some of them may just cancel each other out. All kind of things can happen. Therefore, it's going to be very, very important to work out the numerator and denominator at the same time, simplify if necessary, and then go for the zeros and poles. So we're going to work those out separately anyway, then why don't we combine those two together in the same step? And that's what we're going to do here. Ready? Okay, let's go. Here's the first example problem, and that is the easiest one. Many fractions, so let me expand the font. Okay, here we go. Step 1, the y-intercept and the horizontal asymptotes. Plug in x equal to 0, we get constant terms a0 over b0. That's straightforward. That's the y-intercept. Horizontal asymptote, take the leading terms only, x squared over 2x squared, simplifies into 1/2, so we get y equals 1/2. That's a horizontal asymptote. First, last. First terms, last terms. Want to see the graph? Okay, here we go. You can graph it with Desmos graphing calculator, but I want to save time, so here we go. We have this graph, and apparently there is no vertical asymptote, but there's horizontal asymptote forming, y equals to 1/2. Here we have 0.5. And as for the y-intercept, it's a little bit difficult to see. But then again, that's because this graph is in -30 to +30. So let's graph it from, say, -2 to +2. Yes, you can clearly see that we have about 0.75, 3/4. So if I do that again, then we get pretty much the same as previous picture. Okay, step 1 is done. Let's go to step 2. Let's look for the x-intercept and vertical asymptotes together in the same step. How do I do that? Factor the numerator and denominator at the same time. The numerator can be factored easily because it's monic. What do you mean by monic? The leading coefficient is 1. In that case, factors of the constant term add up to the middle coefficient. So factors of 3 adding up to 4, 1 times 3, that'll do. So we get x equal to -1 and x equal to -3, both with multiplicity 1. Oops, should have been blue. And how about the denominator? It cannot be factored. As you can see, if you set it equal to 0, then you're going to get an equation with no real root. We have quadratic formula here, and we have negative number inside the square root. That doesn't work, so no real root. So no pole, no vertical asymptote. Let's look at the graph again. No vertical asymptote, okay. And then we have 2 zeros, looks like here and there, -1 and -3. I don't know, it's a little bit hard to tell, so let's graph it. -1, -3, yes, it fits. Let's go back to where it was. Okay, so much for the first problem, the easiest one. There are more, so stop the playback and go through the problems on your own. Well, have you all tried? Okay, let's go to the second problem, B. Okay, step 1, the y-intercept and the horizontal asymptote together. Okay, let's go ahead and do that. Plug in x equal to 0 and you get 0 over -5, so y equal to 0. So that's the y-intercept. That was easy. Horizontal asymptote, almost equally as easy. Take the leading terms only, x cubed over x to the 4th power, so we get 1 over x. When x is big, then going down to 0, so we get y equal to 0. Here's a graph, and as you can see, yes, y equal to 0 here, graph is running through the origin, that's y-intercept, and then we have the x-axis, y equal to 0, as the horizontal asymptote. You can clearly see that. So much for step 1. Let's go to step 2. Factor the numerator and factor the denominator. The numerator is a little bit easier. There's GCF, the great common factor. Take it out, take x out, and what's left is quadratic. So you can factor it, and it'll turn out to be a complete square. So you're going to get something like this. And then you can have x equal to 0 coming from the first factor, and x equals to 2 from the second factor. Actually, you can rewrite like this. So x equal to 0, there goes 1. And then x equal to 2, there goes the second, and the second one has multiplicity 2. The denominator is a little bit trickier. There's no GCF here. 4th power, 2nd power, now here, that's constant, so no GCF. So this is completely different. So how do we work it out? You can factor it with respect to x squared. So factors of -5 adding up to the middle coefficient +4, -1 times +5 will do, and that's what we have over here. -1 times +5. So we have x squared minus 1 times x squared plus 5. Okay? And then x squared plus 5 is irreducible, so it cannot be reduced any further, but x squared minus 1, that can be reduced further down to x plus 1 times x minus 1. You see, x squared minus 1 squared, so x plus 1 times x minus 1. It works like this, and that gives me two poles with multiplicity 1 and 1 respectively. So we have splitting, and then for this one, multiplicity 1, so cross the x-axis. And this one has multiplicity 2, so the graph will hit the x-axis and bounce back out. Let's see. Here's a graph. And x equal to 0, cutting through. Okay, that looks good. Two poles, x equal to negative 1 here, x equals positive 1 here, splitting. And you can see those behavior better if I localize a little bit further. Negative 1 here, positive 1 there. But around x equals to 2, it's a little bit difficult to see. So let me create another graph. 1.5 to 2.5. So we're plotting the same graph, zoomed very much in here. And then you can see the graph is actually hitting the x-axis and bouncing back out as even multiplicity 0 should do. Okay, alright, let's go back to where it was. That completes the problem. There are more problems, so please take some time to work those out. Let's see. Do you have enough time for some more problems? Maybe not enough time for a complete problem, but let's take some time to go through with at least a part of this problem. Okay, let's go. Step 1, the y-intercept and horizontal asymptotes. Easy. Plug in x equal to 0, you're going to get 0 over negative 5, so that's 0, so that's the y-intercept. The graph runs through the origin. Horizontal asymptote, take the leading terms only, 4x to the 4th power over x to the 4th power. That's 4, so horizontal asymptote is y equals to 4. So if I plot this, then you're going to get some horizontal asymptote forming, and that should be 4. Okay. Okay, you can see horizontal asymptote forming. Okay, clearly horizontal asymptote. Looks like we have one vertical asymptote here. Yes, one vertical asymptote forming here. And then 1, 0 here, one x-intercept here at the origin. Let's see. So these check out okay. Let's go to step 2. How do we work this one out? Factor the numerator and factor the denominator at the same time. If you do that, you're going to get that. And the detail is left to the students. We have done the denominator before. And as for the numerator, take the GCF out, and what's left is just quadratic, so that's going to be easy. The key point here is to recognize that there is this common factor in both numerator and denominator, which will end up dividing themselves out. So this function here and simplified function there are actually the same, except at x equals 1. At x equals 1, this expression is undefined. We have 0 over 0. This one is okay. So they are not exactly the same, but otherwise they are the same. If you use technology, then it'll just give you this one. So what is the best way to graph that? At x equals to 1, we have a hole there, just placeholder. And that can happen when the numerator and denominator are interacting. Okay, so much for the first half.